Let's consider the following problem. Compute the limit of the sequence that is n to the power 2 plus 1 over n plus 3n divided by 2 times n squared plus 5 as n tends to infinity. Now what you need to notice here is we have, again, the dominating term of n squared, and we have this minor complication that we have also 1 over n in the exponent. Well, let's consider what that gives us. So we have to take the limit of each term separately. So, but first, let me just pull out a n squared from both the numerator and the denominator. So that leaves me with n to the power of 1 over n plus 3 over n over 2 plus 5 over n squared, as n tends to infinity. Of course, we can simplify by n squared now and see what we have to take. Well, in each, taking the limit of each term by applying the arithmetics of limits, what we get here is the limit of the nth root of n, which we might remember, should remember as a special limit that is 1, plus 0, 3 over n leads us to 0, then it's 2 plus 0 again, so this limit is 1/2. Here we applied the arithmetics of limits and the famous limit that is the nth root of n is equal to n, as n tends to infinity. Okay, next, decide whether the infinite series, that is the sum of minus 0.5 to the power k divided by root k, as k is going from 1 to infinity, converges or diverges. This is an alternating series, so we'll apply the alternating series test. Which consists of, well, first of all, the vanishing test. The vanishing test, meaning that the general term in the sequence should converge to 0. So we have to consider the limit of 0.5 to the power k divided by root k as k goes to infinity. For this, all we have to do is to realize that 0.5 is just a half, so that is 1/2 to the power k. That is the same thing as 1 to the power k divided by 2 to the power k. So negative 0.1/2 should be negative 1 to the power k divided by 2 to the power k, and then we'll have this root k in the denominator. Now this expression in the numerator is either +1 or -1. If it's -1, then we can say, if we take it to be -1 for all k, then we get something that's less than or equal to our general term. Okay, if we take it to be +1 for all k, then we get something that's greater than or equal to our general term. Both of which sides tend to 0 as k tends to infinity. So by the sandwich theorem, by the sandwich rule, this limit is equal to 0 as well. Meaning that our infinite series, this alternating series, passes the vanishing test. Which means that it could converge we still have to look further and look at the next condition in the alternating series test, and that is to establish that the terms in the general sequence will be decreasing in absolute value. Okay? What does it mean for our sequence? If we take the absolute value of the kth term, we get 1 over 2 to the power k times the root of k, and that should be strictly less than 1 over 2 to the power k plus 1 times the square root of k plus 1. Okay? Now, if I take, instead of the root of k plus 1, I take the root of k, I'm getting a smaller number in the denominator, a larger one here, but the opposite is also true. I'm getting a greater number here, so we have to rearrange this claimed inequality, so we don't know if this is true at the moment. Let's rearrange it. If we multiply over by 2 to the power k plus 1 and root k plus 1, that should be greater than 2 to the power k times root k. We can simplify by 2 to the power k, and then what we have is simply twice root of k plus 1 is greater than the square root of k, and that is true for all natural numbers. If you are still unconvinced, you can square both sides of this inequality. Since we have positive numbers, it should also be the same inequality if it's true. Okay, so if you are still unconvinced at this point, by rearranging this inequality, you will get that 3k should be greater than -4, or k should be greater than -4/3. So, and k starts with 1, so it is definitely greater than -4/3. So all of these equivalent rearrangements of the inequality hold true all the way up to the first one. So for all k, for all indices k, we have this decreasing property. So by the vanishing test, so by the alternating series test, we have it pass. So the alternating series test is passed by this series. The series converges. Converges.